Welcome to Electric Design of the ST.bonbori channel. I will post a video of 24-volt DC 4 Hz pulse circuit design hard version part 1. I think there are several ways to achieve electric design even for circuits with the same specifications. Regardless of whether it is hardware or software, I believe that the strengths and weaknesses of this method, the personality of the designer, and the experience of the designer will appear. In this video, I would like to explain one of the design methods. Next, I will explain about the table of contents in this video. The table of contents of 24-volt DC 4 Hz pulse circuit design hard version is from 1 to 8 items. In this video, I will explain 1. Specifications, 2. Block diagrams, 3. Main parts, 4. Design of each block circuit. 1. Specifications. The power supply is 24-volt DC. It generates 24 volt of DC and a frequency of 4 Hz to turn on the LED. There is no protection circuit. Electrical, temperature and delay characteristics, dimensions, compliance with various standards, and other details are omitted. 2. Block diagrams. Block diagrams are created for functional units. Create a block diagram while thinking about the main parts. Determine the external signal and power supply. This will make the interface clearer. In this circuit, there is a power supply. There is no external signal. The following is a block diagram of 24-volt DC pulse circuit. Hard version. It supplies 24-volt DC and drops to 5-volt DC. The voltage drop element uses a 3-terminal regulator. Blue is the 24-volt DC area. Green is the 5-volt DC area. The pulse generation element uses a timer IC. The frequency of the output pulse is set to 16 Hz from the resistor and capacitor in the possession. Using a CMOS logic IC, D-latch, divide by 4 to go from 16 Hz to 4 Hz. A photo relay is used to generate a 24-volt DC pulse. It uses a 24-volt DC pulse to turn on the LED. Next, determine the part name and model of the element determined for each block. 3. Main parts. Determine the part name and model of the main element. The 3-terminal regulator is manufactured by TI, and the model's name is as follows. The timer is manufactured by NXP Semiconductor, and the model's name is as follows. Divide the input by 4 with a flip-flop. Toshiba Manufacturing, low consumption CMOS, model name is as follows. The photo relay is manufactured by Toshiba, and the model's name is as follows. LED are manufactured by ELPA. I used what I had in the junk box. For part specifications, please refer to each data sheet. 4. Design of each block circuit. In the TI editor, enter the parts determined by each block. The yellow symbol indicates a new creation. There is no SPICE library. There are no resistors or capacitors. Make connections including resistors and capacitors. Next, each block is designed. 4:1, from 24-volt DC to 5-volt DC voltage drop circuit design. 3-terminal regulator. Manufactured by TI, model LM2940CT 5.0 ND is used. Create a connection circuit by referring to the data sheet. Determine the capacitor from the data sheet. The circuit is as follows. Capacitors. C4 equals 470 nanofarad, C5 equals 22 microfarad. 4 to 2, 16 Hz pulse generation circuit design. Timer IC made of NXP semiconductors, model, ICM7555. Refer to the formula in the data sheet to create the connection circuit. Astable operation mode use. It is the calculation formula in the red frame. In order to achieve 16 Hz, RA, RB, C1, and C2 are determined. The circuit is as follows. Resistors. RA equals 2.2 kilo ohm. RB equals 50 kilo ohm variable resistor. Capacitors. C1 equals 470 nanofarad. C2 equals 470 nanofarad. C3 equals 10 nanofarad fixed. 4 to 3, divide by, for circuit design. Divide by, for uses logic IC edge flip-flops. Made of Toshiba, model, TC74HC74. To generate a divide by 2 pulse, input a 16 Hz pulse to terminal 3 of an edge-type flip-flop and connect the output of terminal 6, bar Q, to the input of terminal 2, D, and the output of terminal 5, Q, will be output by dividing the pulse of terminal 3 by 2. Connect 2 flip-flops and divide by 4. The following are 3 formulas that can be used as a reference when designing circuits. Ohm's law. Kirchhoff's voltage law. Calculating power consumption. Please subscribe to my channel. And if you like this video, give me a thumbs up, because it will encourage me to create the next video. 4 to 4, from 24 volt DC to 5 volt DC pulse switch design. For example, what is the circuit that controls the 24 volt DC and 4 Hz pulse at 5 volt DC? 1. Controlled by logic IC cells and photo relay. 2. Controlled by switched transistor. 3. Controlled by switched transistor and photo relay/photocoupler. For this video, select number 1. Design circuits controlled by logic IC cells and photo relays. 4 to 4.1 controlled by logic IC cells and photo relay. Resistors are connected in series to control the voltage and current of the photo relay from the drive of the inverter. Design the value of the resistors. 2 resistors, R3 and R4, can be combined into a single resistor. 4 to 4.2 determining the value of resistors R3 and R4. The specifications of the inverter, TC74HC04, and the photo relay, TLP241A, that determine the resistance value are shown below. The output high voltage VOH specifications of the inverter, TC74HC04, are shown in the table. The table shows the specifications of the input forward voltage VF1 and input forward current if one of the photo relay, TLP241A. 4 to 4.3 formula for determining the resistors, R3, R4, to be connected to the photo relay. The calculation formula is outlined in red. The target current is F1, 7.5 mA. Assign the minimum value of 4.18 volt to VOH. The resistor value is 388 ohm. I use my R3 330 ohm and R4 100 ohm resistors. The calculated F1 minimum value was 6.8 mA, which is larger than the 5 mA minimum specification. 4 to 4.4 resistor power consumption calculation. The power consumption formula is shown in the red frame. Calculate the current F1 of max. F1 is 9.9 mA. Calculate the power consumption of R3. The power consumption of the R3 is 0.033 watt. It was confirmed that the power consumption, 0.033 watt, of the R3 is less than the rated power of 0.5 watt. 4 to 4.5 limitation on the number of cells used by the inverter. There are -6 cells in the logic IC inverter, but all cells cannot be used in this circuit due to current limitation. In this circuit, it is recommended to use up to 2 of the 6 cells of the inverter due to current limitation. Next, I will explain the reasons for the inverter cell number limit. 4 to 4.6 comply with the current limit of the logic IC. Inverter, TC74HC04, spec from data sheet. Absolute maximum ratings. The output current IOUT specifications are shown in the table. The power/GND current IC specifications are shown in the table. How to satisfy the above IOUT IC conditions. The formula is below. Only 2 cells are used. 4 to 5. LED 4 Hz lighting circuit design. 4 to 5.1 resistors are connected in series to control the voltage and current of the LED at 24 volt DC. Design the value of the resistors, R1, R2. 4 to 5.2 determining the value of resistors R1 and R2. LED specifications are required. The input forward voltage VF2 specifications are shown in the table. The input forward current IF2 specifications are shown in the table. 4 to 5.3 formula for determining the resistors, R1, R2, to be connected to the LED. The calculation formula is outlined in red. VDD is 24 volt. The target current is IF2, 5 mA. The resistance value is 4.4 kilo ohm. I didn't have a 4.4 kilo ohm resistor, so I used R1 2.2 kilo ohm and R2 2.2 kilo ohm. The IF2 5 mA is small compared to the specifications, but there is no problem with light. 4 to 5.4 resistor R3 power consumption calculation. The power consumption formula is shown in the red frame. Resistor R3 is 2.2 kilo ohm. The current IF2 is 5 mA. Calculate the power consumption of R3. The power consumption of the R3 is 0.055 watt. It was confirmed that the power consumption, 0.055 watt, of the R3 is less than the rated power of 0.5 watt. 4 to 6. 3-terminal regulator drive check. Power consumption table. The total power of this circuit is max 0.67 watt. The drive power of the 3-terminal regulator is max 5.25 watt. It can be confirmed that the 3-terminal regulator drive power is greater than the power consumption of this circuit. Thank you for watching. Next time, I'll post about circuit simulation. Please subscribe to my channel. And if you like this video, give me a thumbs up, because it will encourage me to create the next video.